So we're talking about cognitive evolution from a Piagetian perspective. And I am going to place here for you to see a chart showing Piaget stages and our modifications to the chart, or our annotations to the chart. The current thesis of this channel is threefold. Piaget's formal operations stage first appeared about 6,500 years ago. 2. A new structure stage of human cognitive development first appeared about 200 years ago. And 3. The new structure stage has been a key to many of the major innovations appearing in the early 20th century, including relativity, quantum mechanics, computer science, information theory, as well as Piaget's own theory of cognitive development. At the base here, we see the sensory motor stage, which is actually 6 stages when you look at it in detail. The pre-operational stage follows the sensory motor stage. For our purposes, the term pre-operational says more about what the child does not have than what the child has. So we would prefer cognitive representation as the characterization of that stage. Following that stage, we have concrete operations, or what Piaget calls concrete operations. He's using the term concrete to distinguish over the formal operations of the following stage. We think that, again, we're just looking at the accomplishment, not the limitations, so we would call it reversible operations. Piaget would consider that term redundant because to Piaget operations are reversible, as I understand it. But in general, operations in mathematics are not necessarily reversible, so we'll say that the main characteristic of concrete operations is reversible operations. What Piaget has called the final stage in human cognitive development is he calls formal operations. But he also says, I don't think that that's the main characteristic that people relate to. Adolescents in formal operations tend to form and use systems and theories, and so I'm going to call that the systems stage. And according to Piaget, this stage essentially requires somebody entering into a large enough society so they aren't necessarily familiar with everybody in it. And so I would say this stage maybe first appeared in evolutionary terms around 6,500 years ago with the first cities, the beginning of history, and the beginning of written languages. After formal operations, I believe that a new stage, evolutionary event, occurred about 200 years ago. We're calling that stage structures. And we've already had a post that I've made on Galois. Eventually we're seeing Galois as sort of the as at least the oldest, his work, the oldest known instances of work associated with the structure stage. So we're claiming that the structure stage is sort of a sine qua non, something that was required in order for the advances such as abstract algebra, which is what Galois started with his group theory and some of his other events. And by the way, even though we talk about Galois and sort of the tragedy that he died at age 20 in a duel, or due to wounds from a duel, and gee, what could have happened if he had gone on and lived? He was not all by himself. There was another guy, his last name was Abel, I think from Norway, and who was doing much of the same thing. So it's not as though the structure stage would not have been reached if it were not for Galois. It would have been reached no matter what. It's just that he was the first that we know of. And we're saying that this stage had a lot of effect on mathematics. It's basically gradually took over all of mathematics in the 19th century, towards the end of the 19th century. And then as the 20th century began, we have Einstein coming up with the special theory of relativity, then the general theory of relativity. We have quantum mechanics appearing with the Heisenberg uncertainty principle, Gödel, however you pronounce that, proving that the formal operational efforts to sort of come up with a complete and consistent formalization of mathematics or logic was doomed to failure, sort of turning people's metaphysics on its head. A similar advance by Turing to show that the halting problem could not be solved, I guess, and which was a step towards the development of computer science and later information theory. And then Piaget's own theory of cognitive development is a structuralist, requires that level. So Piaget, even though he did not say that there was a structural stage after the formal operational stage, he in fact was in it. Probably earlier on, you're not really aware that you're in a different stage. But one of the interesting things I've noticed, that his statement that it was a final stage, or his statements along that line, I haven't done exhaustive research on this, but those things were statements made in the 1950s. And after those statements, he began collaborating with people, logicians and mathematicians and physicists. There's a whole series of books called the Etudes. I think they're like 37 volumes in the series, many of them involving collaborations with people in other fields. And I think through that he began to see the relationships between what he was doing and what was happening outside of human cognitive development, again, in math and logic and physics and biology. And in response, he wrote what I think are two of his greatest books, and there might have been more in this series, but these were in the late 60s as opposed to the mid-50s of the adolescent book that he wrote, and the 6 Psychological Studies. And these one was called Biology and Knowledge, and the other is titled Structuralism. And these two books, I would say, set out the fundamentals of and sort of demonstrate the power of Piaget's thinking, and therefore of the application of structures to the kind of problems that he was dealing with. So I think, despite the fact he didn't say they were a stage, that they were a new stage of development, there's a different way of thinking. And it's very powerful, and it applies not only in one area of science, but in many areas of science. And we would have to think about this, but must also have influence on a person's perceived role with respect to society, or I suspect societies in general. One of my ideas is that, you know, as the 20th century began, transport, you know, we have cars, airplanes are making world travel more of at least something you can visualize. We've got World War I and then World War II, where we're being essentially confronted by powers that, you know, far away, and it became more and more important to see oneself not only as a member of one's own society, but as somebody who has to deal with all these other different societies. And I think this situation would motivate the development of the new structural stage of cognitive development. Thank you very much.